All right, in this video, we're going to discuss how to calculate a confidence interval for the population mean sunflower height. Okay, so these are fully grown sunflowers, and I've measured their heights, and this is a sample, right? So very important to understand that this data is a sample. And what I want to know is, I want to know basically what is the population. I want to know what is the population average sunflower height. Right? And of course, unless I were to collect data on every single sunflower and figure out their height, I'm never going to actually know the answer to this question. I cannot know what is the population average sunflower height unless I have data on the entire population. Okay, so this is the basic problem that we're facing when we have a sample. Okay, so what do we do about it? What we do is we say, oh, well, you know what? I may not know all the data in the population, but I do know the sample mean, or X bar. Okay, and then obviously X bar is not going to be exactly the same as mu. Remember, mu is our population average, right? Mu is the population average. So X bar is not going to be exactly the same thing as mu, right? They're not going to be exactly the same number, but hopefully X bar is close to mu, right? And how close is it? Well, that depends on your sample size, the standard deviation of the sample. So basically what we do is we construct like a buffer zone, and we calculate a lower bound and an upper bound for possible numbers where mu may be inside that interval. Okay, so this is the basic premise behind what is a confidence interval. It's a buffer zone around our sample proportion, or sample mean, where the population mean is somewhere inside of that interval. Okay, and this buffer, right? This is called the margin of error, or ME. So we go margin of error below the sample mean and a margin of error above the sample mean. Okay, and the formula for margin of error, there are several ways you can calculate this in Microsoft Excel. There's a shortcut method, and then there's kind of a longer method. And I'm going to show you both, okay? So the first thing that you're going to need to know, I'm going to go ahead and type it over here, is you need to know what is X bar. Okay, bar. Okay, so to find X bar, the sample average, do average, open parentheses, and then do all of your data. Okay, so I just clicked and held, and then I released when I got to click highlighting all my data. You can see it goes from cell reference A2 and colon to A11. Okay, once you have that, close parentheses and press average, or press enter, and there you go. That's the sample average for this data. Okay, a few other things I'm going to need to know. N, what is N? N is our sample size. Okay. So I could just count how many I have. Also, Excel has this nice formula called count. Okay, and if I type that in and then highlight my data, close parentheses and press enter, I get 10. Right? I could also count 1, 2, 3, 4. I have 10 observations here. Okay. Another thing I'm going to need to know is S. All right. S is our sample standard deviation. So ST DEV, and then there's .P and there's .S. Make sure you press .S for sample. Otherwise, it's going to calculate the population standard deviation. I don't want the population standard deviation. I want the sample standard deviation. So I do .S. Okay? Highlight all of your data, close parentheses, and press enter. And there's my sample standard deviation. Okay? Then I need to say, okay, what level confidence do I want? Right? So for example, I may want to be, so let me write level confidence. I may want to be 95% confident. So I would write 0.95. Right? You can, be 100, or you can't be 100% confident. You can be 0.99% confident or 99% confident. I mean, there's lots of different numbers you can choose here. 0.99, 0.98, 0.97, 0.96, 0.95, etc. Right? So obviously we want to be relatively highly confident. So we want it to be somewhat close to 1. You can't be 100% confident because that interval would basically be any number between negative infinity and infinity, right? So not 100%, but something you can be 0.999% confident, etc. Okay. Next thing you have is alpha. Alpha is just 1 minus whatever your confidence level is. So I'm just going to click that cell there. Okay. Press enter. So 0.05. 1 minus whatever your confidence level is. Okay. And one more thing. In order to calculate the margin of error, I'm going to need to know is my t value. Okay, so this is the formula for margin of error. T, alpha divided by 2, n minus 1. All right, I'll explain what that means in a minute. And then times s over the square root of n. Okay, so this is the long way to find the margin of error. There's a shortcut method that I'll also discuss. The reason why we're using the t is because we have a small sample size. Okay, in order to use t, you do need to assume that these are normally distributed. Okay, so we are definitely making an assumption here. Assume heights are normally distributed. All right, if you do not have that assumption, then you cannot use the t confidence interval. You have to use something more complicated. Okay, so we are going to make this assumption that the heights are normally distributed, and we have this small sample size, so that allows us to use this t distribution. Okay, those two things. All right, so to find this t, I'm going to press it in enter, and then t dot inverse. Okay, then there's this dot 2t option. That's what I want. T dot inverse dot 2t. Okay, then I'm going to open parentheses. Okay, the dialog box is showing up here. Actually, I want it to be showing up down here. There you go. Okay, so just move my cursor. This little formula box matches this formula box down here. Okay, so probability, you want to give it the probability. That's basically going to be this t, or this alpha divided by 2. But I don't have to worry about dividing it in half because the t, this 2t thing will go ahead and divide it in half automatically for me. So I just need to give it that this alpha level here. Okay. Then the degrees of freedom, that is our n minus 1. Right? So I can just type, click on that cell and then stay minus 1 there. Okay, close parentheses and press enter, and there we have it. Okay. All right, so then I have everything I need for the margin of error formula. Oops. Margin of error. Okay, so this equals this t, right? So this guy, times this s, right? There's s right here. And then I write the division bar. Okay, SQRT stands for square root. And you need to open those parentheses. And then square root of what? Square root of n, which is this guy right here. And close parentheses and press enter. And there's my margin of error. The shortcut method for doing this is to use this equals confidence.t. There it is right there. Confidence.t. This is the shortcut method. Okay, it wants alpha, which is this guy. It wants the standard deviation, which is this guy. And then it asks for size. Size is your sample size, so that's n. Okay. Close parentheses and press enter, and so you get the same thing. Okay, so you can use the formula, or you can just go straight to it using this confidence.t guy. All right, either way, once you have your margin of error, you need to take your sample mean and subtract your margin of error to find this lower side here. And you need to take your sample mean and add on the margin of error to find this upper bound here. Okay, so the lower bound will equal the sample mean minus the margin of error. Press enter. And the upper bound will equal the sample mean plus the margin of error, and press enter. Okay. Once you're here, you have your final answer. You can round it off. If I go home, and I press these little rounding buttons. Okay. I'm going to round to 1 decimal. All right. So now I have my confidence interval. How do I interpret this? Very important. All right. Let me go ahead and write my interpretation down here. So what do I say? I am 95% confident. All right. So 95% confident is based off my confidence level. All right. That the population, this is what I wanted to know. I want to know something about the population average sunflower height. All right, I'm interested in knowing something about the population average, not the sample average. I know what the sample average is. What I do not know is what is the population average. So I am 95% confident that the population average sunflower height is between 52.0 and 61.6. I don't know if I mentioned this before, but this is in inches. Okay, so this is my interpretation, right? So if you're writing an interpretation, it should be very similar to what I've written here, right? And just to kind of talk about what this means, okay, what does it mean to be confident? Basically, we have so if I have a number line, okay, I don't know where on this number line the population average mu is, right? I don't know. That's the whole problem. I don't know what the population average is. For the purpose of this conversation, let's assume mu is 54. Okay, but I don't know what it is. So what I do is I go out and I collect a sample. Okay, and what was my sample average? My sample average was 56.8. Right? Of course, it's a random sample. It's not going to be exactly equal to 54. It's 56.8. This is my sample average. Right? And I could go out and get another sample. Right? I don't know if I have the resources to do that, but suppose I do, and I get another sample, and their sample average is, let me change that actually. Let's change this to 53. Okay, so I could go out and get another sample, of course. You know, they're random samples, so this one might be 55, right? Every sample average is going to be slightly different. So the 95% confidence interval, right, it went from, actually, let's see. So I could calculate a 95% confidence interval for this sample average, right? And I did. It was 52 to 61. 52. Oops. Let me go back. 52 to 60. What was it? It wasn't 61. Or 61.6. So 52 basically to 62. I could calculate a confidence interval for this guy. I don't know where it would be. I'd have to do that math. But I could calculate a confidence interval for it. And I could calculate a confidence interval for this guy. And I could keep on like this. Now, some sample averages, you can see how each of these confidence intervals contain 54, right? 54 is right here. So each of these confidence intervals contain the population average. But I could get a random sample that's just like really weird. Like I just happen to find like a bunch of really short sunflowers just by random chance. And this confidence interval does not contain the population average, right? So if I were to have that confidence interval, I'd say, oh, I'm 95% confident that, I'm between, the population mean is between these two. Well, in reality, of course I don't actually know reality, but the reality is that the population mean is not going to be between that lower and upper bound for this guy, because that was a really weird sample. Okay. But what I can say is that 95% of these repeated confidence intervals, so 95% of these confidence intervals will contain mu. All right. And so that is the, how we interpret confidence intervals. And I know it's a strange kind of interpretation. So, I wouldn't worry too much about it, but this is basically what's going on. So most of these confidence intervals will contain the true population mean mu, right? And of course that's unknown. And we don't know which ones contain and we don't know which ones don't contain. So my confidence interval, it may, or this confidence interval here, 52 to 61.6, it likely contains the population mean mu, but it may not contain the population mean mu, right? But what I can say is if I were to do repeated sampling, 95% of the confidence intervals will contain that population mean mu. Okay?